Okay. Good morning. Now let's get started. Um, First of all, let's take a look at our syllabus. So we have already spent 2 weeks on data exploration, right? And this like exploratory data analysis is a very important task in business analytics. As I keep mentioning to you, before we building model, making prediction, that things typically will be covered in a lot of the other courses, right? So maybe it's a good idea that we spend more time on this exploratory data analysis technique. We already said a few times, right? What is the purpose of exploration? What is the purpose of data exploration? You get the data. Why you want to do exploration on the data? We know what we are doing, right? We were clean up the data. We were aggregate the data, right? I told you the most important thing is we want to summarize the data based on the unit that we are going to research, right? If we want to research product, we aggregate data so that the data is one record per product. If we want to investigate customer, so we aggregate the data so that every record represent customer, right? So this is the data aggregation, data cleanup. And then we use the data visualization technique, right? To compare, right? You visualize the data to compare the individual, to compare the groups. Now you know the group characteristics, right? And you want to design your strategy based on your understanding of your product, based on the understanding of your customer, right? So the purpose of data exploration, in practice, what is the purpose of data exploration? Anyone can do a statement in one sentence? Why should we do data exploration? You are running a business, right? So you want to via the data you want to do what? You want to have a understanding, right, of your business, right? You explore the data so you understand your business, right? In a holistic, in a systematic, right, way. You want to like understand your customer, understand your product. You want to understand where your revenue come from, where your product come from, right? Now you have understanding of yourself. Now you must are you satisfied with what you are right now? Mostly not, right? That's because we are not satisfied with what we are, so we need to do improvement, right? And that's why company will hire manager to do so, isn't it? Right? We are in the business management college, right? So what does manager do? Is to understand where you are and try to do improvement. Right? Now, before you do improvement, you want to know the direction, right? You want to know the goal, isn't it? You know where you are, and you need to determine where you want to go, right? In which direction. and where is the next milestone, right? That is called strategy, right? And that is what I want you to do in your midterm report. Okay? So far you're just already doing this, right? Like dig into the data, try to find some impactful, some insightful information, right? I mean impactful because that information is important to the business, right? I mean insightful, by insightful I meant the thing that if you only look into the data, if you only do a summary statistics, you would not see that detail, right? Okay? So that is what we are doing now. And we have spent 3 weeks on that, and I will try to make it make you have a better understanding of these things, right? Okay. Of course, that will squeeze out some of our time on the rest of the course, but I still think that it is very important to get you a good background on this data explorative technique. Okay, so last week we already go to our unit web page. It's still the unit 7. I basically split the unit 7 into A, B, C into 3 things because of the amount of its content, right? And last week we introduced 2 different type of technique, right? I mean, beyond data processing and data visualization, last week we covered 2 analytical method, right? What is the 2 analytical method that we have covered last week? Anyone? Let's give out some gift, okay? Besides data processing with dplyr, besides data visualization with ggplot, right? Besides data processing and data visualization, we learned 2 analytical methods last week, right? What is the 2 analytical method? Still remember it? What's that?
Clustering and dimension reduction.
Right. It's clustering and dimension reduction, right? Still remember this? Now this is the data, right? I mean the shape of the data is always like this, right? So every row is one of the subject of our interest, right? It could be a customer, could be a product, could be a product group, could be a customer group, right? And every column is the attribute of that subject, right? Okay. Now sometimes you have too many subjects, right? Even like in this case, if we are talking about transaction, we have about like 200,000 transaction, right? Talking about customer, we have like more than 30,000 customer. So if you want to visualize everything, it's gonna make your plot like too crowded to be readable, right? Isn't it? Right? So in order to reduce the number that you can compare, right? You want to segment, you want to group your customer, right? Based on their similarity. You want to identify groups of customer with similar attribute, right? Okay? So that you can compare them, you can get their characteristic and understand in a holistic, in a systematic way to understand your customer, right? Isn't it? Okay? So when you have too many observation, when you have too many subject to compare, you want to group them before you do the comparison. And that is the purpose of clustering analysis. Okay? So now in the other direction, in this direction, we have a similar analytic method. We call it dimension reduction, right? So what is the purpose of dimension reduction and how does it work? And that is what we are going to cover this week, right? Okay? Last week we already covered we already covered clustering analysis with a business example, right? Still remember the airline case, right? So you have like you have a lot of this should be the airline customer, and we are using this loyalty program, right? The mileage program attribute. We group the we group the customer into like how many groups? 5 groups, right? Okay, so and then after we do the clustering, the first thing we want to do is to know the group size, right? Okay, right. So how large is each group, and then the second thing is to understand their group characteristics, isn't it? Right. So how can we know the group characteristics? I mean, we have a chart, right? So we compare the group characteristics, isn't it? So how is the data come from? I mean, this variable is already there, right? I mean, these are the existing variables. So after we do the clustering, we simply do the group average, right? We simply do the group average on all of this variable, and then we can put the group average together in one chart, so we can compare them, right? See? So after compare them, we will see that, right? We will see the distinctive characteristic of each of this customer segment, right? So as long as you know the difference between the customer segments, right, you can design a different strategy, right, to deal with this group of customers, right? That is how and why we do clustering. Is there any question about this up to this point? It's good, right? So so today we will give you another example. I will start with another example to cover dimension reduction. Okay, so as we already mentioned, cluster analysis is try to reduce the number of in this dimension, right? And dimension reduction is try to reduce the dimension in this direction, right? So that you can see, so that you can compare subjects better, okay? Well, the mathematics could be very difficult to, it's too abstract, as you said. It should not be difficult, but it's too abstract, so you cannot have a concrete idea. So I will try to use this perception map, okay? I'll use the unit 07D. I'll use this notebook to give you the understanding about how we apply this dimension reduction technique on business data. Okay, so I might have already told you that in marketing, usually we use clustering for customer segmentation, right? And usually we use dimension reduction for perception map, which is the thing that I want to cover for the rest of the hour. Okay. So let's go to 7D. Well, it looks like okay, it's fine. Okay, 7D I told the title is called MDS. It's standing for multi-dimension scaling. Well, when we do clustering, I mean clustering has a lot of method, right? You can use hierarchical clustering. You can use k-means, right? Same is dimension reduction. They are a lot of different methods. In this notebook, I will kind of demonstrate two different methods. But actually, in the R environment, the method is not that important because you basically use whenever there's a method, there is a function call, right? So you only need to know the function call. You know what kind of data need to what is the format of the input, and you can understand the output, and that's good enough. Okay. So let's see the data first. Okay. Now, after loading the package, our data is called cafe. Okay, so well, unfortunately, this data set is actually have some Chinese character in there, but basically it's a 5 cafe brand. Okay, and this one is Starbucks. This one is Dennis. Okay, and this one is 85 degree. This one is One Cafe, another brand. So in this dimension, we have 5 different brands of cafe. It's the like cafe store, right, on the street. And in this direction, we have like brand characteristics. This data actually come from customer survey. There are some marketing survey company, right? So they send they deploy some questionnaire, right, to ask the customer of the cafe, right? So they try to get the attitude, try to measure the attitude of the customer toward the brand. Okay. So there's a survey, there's a marketing survey. Now you use questionnaire. They measure the customer of cafe on a few brand characteristics. Okay, so this is the product style and the holistic company image, something like that, right? So these are the like the attribute of a brand. Okay, so for those who cannot read Chinese, these things are actually the characteristic of the brand, right? So is it professional? Is it trustworthy? Okay. Do you know the brand? What is your attitude toward the brand? Is it positive or negative, right? What is the image, the social image of the brand? That type of measurement that that you can acquire from a market survey. Okay, so the data is quite simple, right? It's a metric, and in the row dimension, it's the brand of cafe, and in the column dimension, we have a series of brand related variables. Okay, so what is our purpose? we want to compare, if I'm one of the brand, right, I want to compare my brand with the rest of the brand, right? I want to compare myself with my competitors, isn't it? Right? And that is what we are trying to do with this data, okay? Now, this data, if we go back to this slide, we only have 5 rows, right? But we have 8 different variables, right? So we want to compare the 8 variable across this 5 brand, right? We want to put them in one single picture, okay? In one plot, I would like to compare 5 brand with 8 different attributes. And because there are a lot of attributes that we want to compare, that is where the difficulty kicks in, okay? And that's why we want to use dimension reduction, okay? Right? When we are comparing 2 attributes, it's easy, right? Because I can use one attribute as the y-axis, and I can use the x-axis to represent the second attribute, right? So when you plot the brand in this dimensional space, in this 2-dimensional space, or I can see that when I plot my subject in the variable space, it's easy to compare, right? If they are like 2 dimensions. But what happens if you have like more than 2, right? In this case, we have 8. So how can we do that, right? So as I told you, the dimension reduction can like reduce the dimension, right? It reduces the it will try to compress the high dimensional variable space into low dimension. Usually you will compress into 2 dimension, okay? So before we see the code, let's see the result. This is the result of the dimension reduction, okay? I mean, with this data, it's very difficult to see, right? How can I compare the brand with this like chunk of data? Okay, but after dimension reduction, I basically can plot the variables and also the data point together in one plot. Okay? All right. So this is a metric, right? So we have 5 brand. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 attributes. And here, every red line represents 1 variable, okay? And every black dot represents a brand, okay? So I can compare the 8 attributes across this 5 brand in one single plot. And that is what we mean by dimension reduction. Okay? So in this plot, it's very easy to tell a few things, right? Now, first of all, I can see that these three brands, they are similar, right? The closer they are, the similar they are, right? Okay. I can see that Spark and this ideal brand, these 2 brands, they are relatively more different than the others, right? Okay. And not only that I can tell their similarity, I can tell what is different, right? Because the Starbucks is good in this 2 dimension, right? Dimension is a thing that if you have a higher coordinate, you have a higher score, right? Okay, so whatever in this direction has a higher it's more popular and it has a higher company image. Okay, I mean every every variable is representing company attribute, isn't it? Right? Okay. So and these two things, one of it is the popularity. Okay. The other thing is the company image. Okay. So we can see that Starbucks is good in these two things, right? Okay. And idea brand is good in product design, product style, and also the trustworthiness. Okay, the trust. Okay, and so and these three brands actually are good in the variety of product. Okay, sorry, I should have translated this into into English. I just forgot to do that. So in the plot, I can tell, if for example, if I'm I'm this brand, right? I can tell that I have three different type of competitor, right? And two competitors that are close to myself, okay? And this competitor is better than us in popularity and company image. And this brand is better than us in style and the holistic product for this and the integrity, right? Product integrity, right? So not only you can tell where you are, you can also see where your competitor is. Where your competitor is. You can see your own location and comparative to your relative to your competitor, right? So you know your position, you know where your customers are, right? So you can decide where you want to go, right? So as a manager, this is what the data told you. This is what the data tell you, right? So by looking at this chart, if you are the brand manager, you can decide where you want to go, right? Right? So these are the brand characteristics, right? So if you want to improve your brand image, now you have a lot of different way to do it, right? So dimension reduction is another technique to show you a strategic space, right? To see the strategic space. So in this strategic space, you basically can see three different things, okay? First is first of all, you can see the similarity among the data points, right? And the second thing is, you actually can see the correlation. See, if for example, these two variables, they are basically in the same direction, right? So so they it implies that they have a higher correlation. Okay, it means that within the survey, if a company has a higher variable 1, you will have a higher variable 2. Okay. So we can see from the direction of the original dimension, I should say that. Okay. The original variable, we basically can see the correlation, right, amongst the variables. Okay. And the third thing, and maybe perhaps the most important things, is you can tell the relationship between the variable and the data point, right? So you see that this data point is good at these two variable, and this data point is good at these three variable, right? Okay. So in single chart, you can compare a lot of attribute across a lot of subject, right? So you can see the difference. not only you can see where you are, you can actually see where your competitor is, right? And and based on this information, you can decide your strategic direction, right? Where do you want to go, right? If I am this brand, should I go this direction so I'm closer to Starbucks? Do I want to go this direction so I'm closer to this brand? Or maybe I can go this way, right? So that I can, like, you know, the blue sea theory, right? If you want to have a unique brand image, right? So so your brand image do not like these three brands, they are overlay with each other, right? So if your brand image are overlay with your competitor, well, you're basically appearing the same customer segment, right? So can I go to a place where nobody is there, right? So I can have a niche area, so I can have a niche brand, so I can like acquire a customer that no one has covered yet, right? And that is the blue sea strategy, isn't it? Right? So before you can go to the blue sea, you need to have an idea about where is the Red Sea, where is the blue sea, isn't it? Right? So this kind of tool will help you do that, right? Okay. This chart is what we call perception map, because it's a brand perception, right? Usually you will come from marketing survey. Okay. I deploy questionnaire to maybe like 300 consumers, cafe consumers, right? And then I ask each consumer, ask them to evaluate the brand, right? And then after I gather the questionnaire, I do the average, and then I have this matrix. It is easy to generate this matrix, right? But it's very difficult to read the matrix, to read information directly from the matrix, isn't it? Okay? Let me say it again. It's easy to get this matrix, right? But it's very difficult to compare so many brands in so many variable in data like this. And that's what dimension reduction can help you. Okay? You got the point? Okay. So let's see how we can do a dimension reduction in R. Okay? So the notebook should be under the directory of 7, right? Okay. So oh, by the way, in the material under the material folder of unit 7, I renew the zip file. Okay, so I already updated the zip file, so you might want to, especially for this Tafang, I put some new notebook in this Tafang data set, right? So after we finish the first hour, I would suggest you like download this tafang.zip again. So starting from next hour, we will have some new in order to help you prepare your midterm, right? I add more content on this tafang folder. Okay, so download this tafang.zip and just cover it on the original content. Okay. Okay. Now let's take a quick look at Notebook 7D. And as usual, this is just to load the package and load the data. And as you can see that this is the data, right? Very simple. But even we only have a very small matrix, it's still very difficult to read, right? People's the people's brain, the human brain is not it's not designed to like understand the things like this, right? That's why we need the visualization, right? Okay, so in order to visualize this phi brand in the A-dimensional space, it's difficult, right? So we use dimension reduction, try to compress the high dimensional data into low dimension. Now, how to do it? Now, there's a scale. First of all, we can do a multi-dimensional scaling. This is just another way to do dimension reduction. Okay, so again, we need to do a distance matrix. Still remember that when we do the clustering analysis, I told you that we want to scale the data and then do a distance matrix, right? Because when we all of these multivariate methods, by multivariate method I mean the method like clustering, like dimension reduction, right? They basically would map they basically would treat every variable as a dimension, right? Okay, they basically treat every variable as a dimension, right? And then they kind of map every data point into this high dimensional variable space. Okay, so all of the method mathematically they are calculating the distance of the data object in this high dimensional variable space. Okay, I mean mathematically that's how they do it. Okay, so first of all we put this cafe into the distance function, and we calculate their Euclidean distance. Actually, you don't need to do this. By default, it's already Euclidean. Okay. You know what is Euclidean distance, right? It's just the basic distance idea that we know in space. Okay. So you have 2 points, and that is the distance. Okay. Euclidean is a guy, right? It's a Greek guy. The ancient, one of the ancient guy, right? Ancient philosopher. Okay, so you don't really need to do this. You simply want to do a distance matrix. So let's see how we will get. If we have a distance matrix, we will see something like this, right? Let me see if I can. See, you can see that this is the distance matrix. So this is the distance between like the first band and the second band, right? You can see that it should be a matrix, right? But you don't need to be, because if we put the distance from A to B is always the same as the distance from B to A, right? I mean, it don't need to be a matrix. Because if I put it into a matrix, it will be a lot of duplicated data, right? Because the distance from A to B is always the same as the distance from B to A, right? So you don't need to be a full matrix. You only need to have a lower triangle of a matrix, right? So this is the distance matrix. Calculate the matrix, And then if we want to use this method to do dimension reduction, the function code is like this one, CMDS, and like I think this is also the default value. You don't need to do that at all. Okay, so after the dimension reduction, the result will be here. Okay. So as we can see that we will have an object, just like we do a hierarchical clustering, right? Every time you call algorithm, okay. By algorithm I mean the things like hierarchical clustering, k-mean clustering, like principal component analysis, like whatsoever analysis. Okay, in R it's always the same. There is a function call that do this for you. Okay, the only thing is you need to know what input is required, right? And in this case, the input is the distance matrix, right? Okay, so you give it the input, and the function will actually perform a dimension reduction for you, and it will return the result to whatever object name you want to assign to it, right? Okay. And this symbol, as I told you, is exactly the same as the equal sign. Okay. So this is the expression, right? And after the evaluation of this expression, the result will be kept in the object called fit. Okay. So we can plot the fit. Now, plotting the, okay, let me go back to the notebook. If you want to do a dimension reduction this way, right? Okay, you will need to make a plot by yourself. And the procedure is actually, you can see, it's quite complex, right? Okay. But I just want to tell you that there's another way of doing dimension reduction. Usually, we will not do dimension reduction in this way. If you want to like plot like this, you will need to write a very lengthy code to do that. And I don't think you need to learn this at all. Okay. The easy way to do dimension reduction is simply call PCA. Is simply to call this PCA function, right? Now, in this PCA function, the dimension is done in one single function. Okay, let me show you. Okay, let me show you. See, before I do that, let me explain it again. Okay, there are many different ways to do dimension reduction, and the results is usually very similar to each other. Okay, so so usually we will use the most convenient way to do dimension reduction is this PCA, right? Okay, so for this PCA, you simply give it the data, and it will do everything for you. Okay, already. Let me show you. Let me create a new code chunk for easier explanation. So if I want to do PCA, I simply do this. See, I only want this X and Y, they are not original data, right? They are produced in if we read in the data, we don't actually have these two variables. These two variables is produced when we do the MDS. Okay, let me read the data again. If you read in the data, they are actually A variables, right? Okay, so basically I can like simply do this, right? After reading the data, if I want to do dimension reduction, I simply do this, okay? I just give the data to PCA and it's done already. As you can see that it would plot the variable, it would also plot the data point, okay? All right? And it actually will also give you the result of the PCA, okay? So if you want to keep the result, you can like actually keep it in a thing like this. And then you can keep all of this result, okay? But usually for our data exploration purpose, first of all, we don't really need to look into the detail of this data, okay? We only need to use the chart. And when we make the plot, we don't really want to plot a variable in one plot and plot the observation in another plot, right? We want to plot them together, isn't it, right? And that's why we want to use this code. I told the PCA by default it will generate two plot, okay? I told it no, I don't want your plot. You simply give me the result, okay? So if I do this, sorry. I told it don't do the graph. So it will only be the results of the PCA, right? So usually I will use this function to generate a plot. Okay, the plot will be it looks better basically. So I pipe it to sorry. So I pipe the result of PCA into a plotting function. It will generate a PCA by plot. Let me show you. Okay? It will show you a PCA by plot. Okay? So it will plot the variable and the data point together, right? Okay? Right? So it's and every time you make a plot, you always need to tweak the number, the size of the label, right? The color, if you want to make it looks better, right? That is what this argument do. There are a lot of arguments, right? As you have learned in the ggplot. Plotting function always have a lot of arguments, right? So and then we have no time to cover all of them, right? So you simply the easiest way is to try to keep this notebook, right? And next time you want to do a PCA by plot, you simply kind of reuse the argument, right? Isn't it, right? So I mean that you don't need this argument. You can already generate a by plot, right? But if you want to do a pretty plot, okay, so you will need to make some adjustment, right, to make it looks better, okay. So I do not have time to cover everything. You can put your cursor on the function name and press F1, and you will see the online help, right? Okay. But usually you do not have time to do that, right? So the most convenient way is to keep your notebook, right? And next time when you want to plot it, use the argument that I give you, okay? And if you want to change something, then look into the online help, right? Okay, that is the best strategy to use. So the notebook that I give you is important, right? Okay, so you should keep it in your notebook, so you have something to copy, right? Okay, so this is basically how we why we want to do dimension reduction and how we do it, right? To do it is simple, right? You just put the data into this PCA function, and then use this function to make the plot, okay? Okay. This NDS things, I just want to tell you that clustering and dimension reduction, there are a lot of different methods, okay? But for our marketing purpose, usually their result is like the same, right? Okay, so we don't need to use the complicated method. We simply use a function like this, right? A line of code, you can make the dimension reduction, and you can make a dimension reduction by plot. In one line of code. And if you want to make it look better, then you can try to adjust the plotting arguments, right? To add color, to add the other things, okay? So that is the way, and that is why we want to do dimension reduction. Now, let's take a break, and let's get back at 10:15, okay? Let's take a break. And that's start to do something on the Tafang like in the next 2 hours, okay?